In today's video, we're going to be taking a look at time series decomposition, where we take a time series and we break it out to its components of trend, seasonality, as well as residual noise. We're going to go over 3 different examples of time series decomposition, and I'm also going to code it all in Python. But before we jump into the Python programming, I want to go over even more information about exactly what is time series decomposition. So let's take a look at time series decomposition. First thing, it brings the time series into its components. And what are the 3 components of time series decomposition? Well, you have trend, you have seasonality, and then you have the residual, which you'll often see listed as noise. So trend and seasonality can be optional within a time series decomposition, but every time series will have some sort of noise. So let's talk about each of the different component parts, right? So trend is the overall direction of a time series, which may show a consistent increase, decrease, or a mixture. Seasonality is a repeating short-term cycle in the time series. You can think of this like travel months, right? If you're in a tropical place, you're going to get more tourists during this summer. If you're at a ski resort, let's say you're in like a Switzerland or you're in Colorado, right? You might get more visitors during the winter, whereas somewhere like Florida, where I live, you typically get more visitors in the summer because everyone wants to go check out the beaches as well as Disney World. Residual, right? This is the random variation in the series found from subtracting the trend and seasonality components from the original time series. And this is an example of one of the decompositions we're going to be performing in the video. Like with the rest of the series, we've been using the Apple stock 5 years, so we'll be using that as well in this video. We're going to do a few different decompositions. We'll talk about this in 8-bit, but these are the 4 different graphs that will be generated with just a few lines of code. So we'll get into that a little bit later. But first, what we need to know is additive versus multiplicative models. So additive is when you add up your trend, your seasonality, and your residual. So the seasonal variation is constant regardless of the trend, is appropriate when the data does not exhibit any exponential growth or large changes in amplitude over time. It has the same frequency and amplitude. Multiplicative, right, as the word kind of hints at, you just multiply the trend, the seasonality, and the residual. The seasonal variation changes in the proportion of the trend. This is suitable when the data shows growth or decline over time, and the seasonal fluctuations become more pronounced as the overall levels increases. It has an increasing or decreasing frequency and or amplitude. So let's take a look at some graphs, right? So this is additive. It looks a little bit like it's growing, but it's really not in this case, right? This is a better example of multiplicative, right? You can see we are getting larger every time, right? And you can see the spikes continue to get larger and larger. We see a growth pattern, right? From down over here all the way up here. Pretty obvious on this side of things that this is multiplicative. And in that side of things, you would want to use multiplicative decomposition. We'll talk about that in a second. So one other thing about this is real-world time series often are complex and noisy. They might not perfectly fit into either one of these models. Some series contain both additive and multiplicative components, experience shifts between increasing and decreasing trends, or mixed non-repeating cycles with seasonal patterns, right? And also you can possibly convert a multiplicative model to an additive by taking the log transform and differencing, or you can use a box calc. But yeah, so you can do that, and I'll show you also in the video how we do that. And let's take a look at how we can apply the time series decomposition. So you can do additive, right? And the time series is decomposed into the sum of trend, seasonality, as well as residual components. And we're going to use seasonal decompose for that. And we'll go into the code a little bit later. Also, you can use multiplicative, right? And again, you're going to use a seasonal decompose, but you're going to use model is multiplicative. We'll cover that with the coding side of things. And then lastly, we're going to be looking at seasonal and trend decomposition. This is STL, right? And STL is a more flexible decomposition method that uses locally weighted regression to separate the time series into trend, seasonal, and residual components. Use STL when the data has complex seasonal patterns or when the seasonality is not strictly constant over time. It is especially useful when the seasonal pattern changes over time or has irregularities that can't be captured with additive or multiplicative models. And what I want to say is that these are only 3 different decomposition methods. There are tons out there, right? But I'm trying to show you guys the basics of how this works. If you do want to see another video on more complex decomposition methods, let me know. I can make it. But I think this is a pretty good starting point for this series. So make sure to load up your Python notebook and yeah, let's get started coding. All right, let's get started. First thing is I brought in the data, all stocks, 5-year CSV. So grab that from Kaggle, throw this into Colab if you're using it, and we can get going. So what we're going to do is bring in some imports. Import pandas as PD. Import numpy as NP. Import matplotlib.pyplot as PLT. Then from statsmodels.tsa.seasonal import seasonal decompose as well as STL. And then from statsmodels.tsa.stattools import our ADF, so ADA folder, and we are off. Okay, so what we should do first is read our CSV. So I'm just going to call this data frame. So df equals pd.read CSV, and then I'm just going to grab the link to this file. So just go over to the folder, copy path, and just paste it in over here. And now we have our data frame. And up next, what we're going to want to do, let's convert the date column into our date time. So we'll say df date equals pd.to date time, like that. And then just pass in df date. All right. Then what we're going to do is grab Apple. So because this has all the stocks in there, I believe not all the stocks, but S&P 500. So we'll say df Apple equals df name, name like that. All right, equals Apple, and it's all caps AAPL. Their stock ticker dot set index, and we're going to set the index of date. That we have a small error. Name. I thought it was name. Oh, it's a capital N. Looking at my notes. Okay. Up next, we're going to set our time series. So we're going to say TS equals df Apple, and we're just going to grab close like that, and we are off. So what we should do first is plot this. So just to show you what this looks like. So TS plot. And that's if you haven't been watching this series, which I expect a lot of people are here for the first time. So welcome to the channel. We'll say Apple stock closing prices, and then you can set a fig size. So fig size, typically in the videos, 12.6. It does pretty well. And then you can just do plt.show. So plt.show like that. And you can see Apple stock closing prices, right, from 2013 to 2018. That's what this data set from Kaggle uses. I know we're in 2025, so this is such a long time ago, and I'm actually kind of curious what Apple is today. But yeah, so pretty big growth over those 5 years, going from $65. It's probably close to 70, all the way up to 160. Okay, so what I want to do first is look at a multiplicative decomposition. You can see that this grows quite a bit on here, and I think it could be a good start. So multiplicative, and let's get going on this side of things. Now we'll say is multiplicative decomposition equals seasonal decompose, then pass in our time series, so TS. Then we want to set our model, so model equals, and we'll have multiplicative, and then you want to set your period. And period's an interesting one because you can get quite different results by using different amounts of period, and period is the parameter length of one cycle. Okay, and then for period, I'm going to use 252 days. What you typically want to use for your period is some sort of cycle within your data. There's a few different approaches we could use for this. We could use like a week, or we could use a month, or we could also take a look at the year. So I'm going to use that. And because of limitations on trading stocks, I'm going to do, our period is 252. So we'll say equals 252. We're going to change up the period at the very end just to show you how the results look, but not with our first two models, right? So I actually do have an error over here, and you know why? Because it's seasonal, not season decomposition, and there we go. Okay, now to plot this out, it's actually quite easy. So you saw in the slides that we had 4 different plots. All you have to do is multiplicative decomposition, like here. You just do .plot, and then what I would recommend is changing your X ticks, because it will it won't look good, right? So we'll say X ticks rotation equals 45, and you can change your font size too. I'd recommend that equals 10, and then lastly we can show this plt.show, and yeah, I mean there's 33 lines of code to get this, technically 4 if you include that, but this is why if you don't, these are gonna like overlap here at the bottom. But regardless, this is our multiplicative, right? The residual is all above on this side of things. Typically you want to have your residual kind of looking random. This isn't the best use case on the side of things, and also this data isn't stationary right now. I mean, it's pretty obvious it's not stationary. We'll change it to stationary data in a bit. But yeah, so this is our first example, right? And I think it does the job of our first example in this video, but now we want to make it stationary. So all we're going to do is say, let's say a note here, stationary, right? And we'll say log ts equals np.log ts. And then after our log, what we want to do is difference. So say diff ts equals log ts.diff. And then also we're going to drop an A. Should be good over there. And then we can plot this again. So what I'm going to do is literally just go over here and copy our code. This is going to be the same plot, except now we're going to have diff ts, right? And then I'm going to put stationary Apple closing prices, and take a look, right? Now this looks a lot better, but one thing I'll mention is we should take a look at least at one hypothesis testing, or hypothesis test for this. So I'm just going to do the ADF. This video isn't specifically on hypothesis testing, but we'll say ADF test equals our add fuller, and then we'll pass in over here diff ts, so diff ts, and then what we'll do is run that, and we'll grab our p-value over here, and that would be ADF test 1. This is our p-value, and we get a p-value essentially of 0. So we reject the null hypothesis, right, which essentially says it's not stationary. This is stationary data. Awesome. So let's move on now, and let's take a look at the additive. So we'll go over here, additive. All right, so now let's take a look at our additive model. So it's gonna be pretty similar to what we did over here, right? Oh, sorry, I meant to scroll up over here. It's gonna be very similar to what we did for multiplicative. So let's do that, except this time we're gonna use our new data that we already made stationary. So we'll test how that works. And I'll go over here and let's say additive decomposition equals seasonal decomposition. Same thing, right? This time we're going to pass in our new data, which I believe was called diff ts. So we'll just pass that in over here, diff ts. Then we'll set our model. So we'll say model equals additive. And then we'll set our period again to 252. And I apologize for this text getting in the way. You have that there. Should be 1 equal sign. Could not read it. And okay, good. And what we'll do now is set this plot. So we'll say additive decomposition plot plt.xticks. Say rotation equals 45. Font size equals 10. And lastly, we'll show this plt.show. And yeah, so what you can see, this looks stationary on this side of things. We have a different trend right now, right? Seasonal, right between negative 0.2 and 0.2. And our residual is all over the place, which is awesome, right? Now, I just want to show you really quick. I'm curious what this would look like if we used our original data set. So I'll just go over here and I'll call this number 2. And I'll just use TS just to show you the difference, just in case you're wondering. I don't know if anyone's going to wonder or not, but either way, we'll go over here, make this as number 2. And number 2. Cool. So you can see that we still have this original one that we have over here, right? Our first plot, that is our first one over here. Then our trend line looks the same, right? Smooth and everything like this. Whereas over here, this plots our stationary data and has the trend based around the stationary data. And then you can see that there is some sort of seasonality still associated with this. The residual looks way better. Although there looks like there may be some patterns associated with it, but it is spread between both positive and negative residual in comparison to the one which was literally all just positive. But regardless, better to use this one over here with our stationary data. So what I want to do now is take a look at our STL, so our STL decomposition. So we'll just go over here and say STL decomposition. And we will be off to the races. And what we'll say is STL equals STL. Then we'll pass in over here our, was it log or diff TS? Yeah, diff TS. And we'll pass in first our diff TS. We'll set a period. We're going to change the period on this one a few times. So we'll start with 252 and see how that works. So the period equals 252, robust equals true. Right. Next line, what we're going to do is fit our data. So STL result equals STL.fit. That's right. And then we need a plot. So we'll say STL result.plot. plt.xticks, rotation equals 45, font size equals 10, and then lastly show it, plt.show. Right. Again, a little bit different than what we had to do, but you can take a look at this. Our residual, almost around 0, some above, some below. One or two different data points all the way at the end of these graphs. Seasonality, almost over here around 0, hovering, and you can see on both sides. Our trend is way smoother, and we have this over here. And just to compare, like up here, right, the trend is very rigid. So a little bit of difference between our additive as well as our STL at the 252 days. What I want to do though is just to show you guys, like, this can change quite a bit if you change that period. So we did 252, right? And if we take a look at monthly, you'd use like 21. If you use weekly, you'd use 5. So what I want to do is now look at an example of 21 as well as 5, just to see how that would change. So I'm just going to comment this out over here. We'll say 252. We'll go over here and make this 21. I'll just comment that out, and we'll just redo this graph. So we'll go over here, and let's see what 21 looks like. So you can see the trend has changed quite a bit when we moved it to 21. Our season has moved quite a bit as well. Like, we have pretty big amplitude over here, then it gets really small, large, small, and residuals are all over the place. And lastly, let's just take a look at what this would look like with 5. And again, you can play with this, see what works best for you when you're decomposing this. But yeah, I just want to kind of show you guys how these graphs work. So we have a 5 over here. And lastly, we'll do 5. You can see now we have even more on the trend side of things. And then on here for the seasonality, everything like that. So yeah, that is about it for time series decomposition, right? And if you want to see a part 2 in this video, we can definitely do that with some other type of models that are out there, a little bit more advanced. But I think this is a pretty good start to your time series decomposition learning. Thanks guys for checking out this video on time series decomposition. If you found value here, make sure to subscribe to the channel. We're uploading a few different data science videos every single week. Now, if you want to continue this series, I'm going to put a few videos down below in the description, as well as a playlist right over here as it develops. So check them out.